So maybe I'll start by telling you what Indeed is. Indeed is a job aggregator and a vertical search engine that allows you to search for jobs all around the world, and given what you're looking for and where, it will produce all relevant results. You might have seen people from Indeed Prime, which is our branch that is closer to a headhunting solution. So if you're interested in this, you can either search for work with Indeed or approach us directly, as we are a company with over 5,000 people, with up to 1,000 people this year in Dublin, strong engineering office, and we have big data. Like, we have real big data, 200 million visitors every month, and we are collecting something like 25 terabytes of data per day in just unprocessed logs. So there's a lot of stuff, a lot of fun things that you can play with, but one thing that we don't have enough is actually time, because with machine learning things, you can always go out and get more data for your models, collect more faces to train a machine learning tool that will recognize faces. You cannot create more historical data to infer from. So we are trying to spend a lot of money on marketing, and we want to know how effective it is, if we are getting our positive return on investment. And there are very few ways that we can do it, and it's rather difficult. I wanted to include this quote because it's actually not clear who actually said it in the past. So if we can't even get this, how can we be making any predictions about the future? Predicting the past means analyzing what happened versus what we expected to happen, what should have happened if we didn't take any actions. And in marketing tests, especially in offline advertising, by marketing test I mean like a short, intensive period of testing one medium or one message in one specific location, with the focus of getting a specific action, we can't really connect directly what is happening offline with what we see on our website. And the reasons behind this are that we are using TV, terrestrial and satellite radio, direct mail, out of home, and print advertising with things like landing pages, promo codes. But can you raise a hand if you've ever typed a promo code into a field on a website? Like, anyone here? It's not even a half. So it's really difficult to find a direct cause-effect relationship between what we do in offline world and what we see on the website. And because we are advertising to advertisers, asking them to post jobs on our website, even when we reach the right person, we have to do it at the right time. We can't convince someone to create a job if they don't have any jobs to offer. So the way that we advertise is that we are casting a very wide net, and we are trying to reach a wide range of people, and we get very low response. That's something that we have to live with. I mean, if you have one job per year, and we are advertising for 1 week, spending a lot of money on that week, there's 1 in 52 chances that we will reach you on that specific week. If we don't, we just wasted money. So that's one of the problems that we have. Second is that when we are analyzing marketing tests, there's not really any point of reference that we have in the real world. There are no two identical cities. I'm saying here, there are no spherical cows in vacuum for us. Each single place where we advertise will be different than all the other ones. We'll be affected by different factors. We'll have different industry composition. So we cannot really compare Dublin to San Francisco or even to Belfast. And this would be the two obvious, like Dublin and Belfast sound like two obvious similar places to analyze, but they're actually completely different and behave in a completely different way. So we have very limited set of tools that we can use for analyzing what actually happened. We cannot just direct something at some other place and see, oh, we had 5% increase in Dublin, 0% in Belfast. It means we just gained 5%. Instead, Oh, also, each marketing test that we are running is affecting whatever is happening after. If we were running marketing tests in Dublin for, let's say, 3 months, and then we stopped for 1 month, and then we started a new campaign, the new campaign would be affected by what happened in the previous one. You will remember the brand, you will be more likely to convert because you already know the name. So once we run a campaign in one place, it's pretty much burned ground for us. We can't go back for a long period of time. And last point is that we don't really do it in the most valuable markets. We will be testing campaigns in places that are not our primary markets, so that once we find a campaign that is working really well, then we deploy it at scale in the place where we actually make more money. And so when talking about this, there are a few definitions that we all have to know for this analysis. Time series is just data over time collected at equal periods. Response is the value of the process that we are observing at time where we observed. Forecasts are expectations of what will happen in the future based on the past, and the merit of this talk is counter-factual prediction. It is based on what happened before we took actions, what was the expected value if we didn't take our actions. If we didn't advertise, how many people would create accounts? How many people would go to the website? And this term intervention is simply point in time when we started taking actions, trying to convince, to change people, change behavior, to churn less or to advertise more, to spend more money or to search for more jobs. Baseline, what we expected to see, and uplift is simply the difference between what we saw and what we expected to see. And why are we using fbprophet? Using brackets here because this tool is actually available in Python and R, if anyone is into using R. Not here, I guess. It's easy, it's fast, it's not a particular model, it's just a framework that you can use for simplifying, for streamlining the process of conducting the analysis. The underlying model is is written in Stan, it's a simple linear model with non-linear trends, separating or decomposing our response into overall trend and weekly and yearly seasonality. It's robust, handles missing data, but of course it's not that easy. We have to have enough to infer from. And also it works with sklearn, so we can include it in the pipeline very easily. It's a simple off-the-shelf tool that should be like your first thing to check when you're running any analysis to see if there's any point in even trying to, before you start tweaking the parameters, before you start going in depth into what would actually be the right model. And now, because we are analyzing time series, we don't have that many tools to check how good the analysis is, how good our predictions were. So the approach that we are using is to train, test, and retrain. So basically we have our time series and we have our intervention date after which we are expecting to see results. And we are testing the model by training it on as much data as we can before our intervention date, leaving out the small test period, which we'll use for evaluating how good the model was. And after obtaining our prediction errors, we then use all of the data all the way up to the intervention date. We make the predictions, and we assume that the model at this time, because it has more data, should not be worse than the one that we had before. There are some pros and cons, problems with this model. First of them is that we assume that our action was the only action that was taking place at the time, and it's actually the one that is causing the change in the process. If we were unlucky enough to start a campaign on the day that Brexit was announced, and we are measuring the number of jobs posted in London, we would conclude that it was our advertising that made people search for jobs and post less of them. Right? that's not exactly true, but we can only know as much about the market. We don't know exactly everything that's happening over there, so we have to make assumptions, and this is what is causing sometimes a lot of problems when trying to make any conclusions based on the analysis. And the second is that we basically try to minimize the impact of previous campaigns on the campaign that we are running right now. So we give it enough time for people to, let's say, forget what Indeed was, so when we advertise again, they will learn again. Doesn't always work this way. The long tail of the effect is something that if someone here could really analyze, they should open up a startup and make millions, but we just assume that it doesn't exist. And with every test that is run after the previous one, we have to increase the budget so that the effects that we will see will be bigger than the ones that we expect from the previous campaign. And we are looking for change, so we tried, like, there's a bias in the analyst's mind that we are looking for change, we are looking for uplift. There are marketing directors asking us what was the effect, and we are trying to find it even if it doesn't exist there. So that's one thing that we have to keep in mind, that just because we want something to happen and our analysis is telling us it happened, we still have to validate that is true. The pros of this approach are that it's fairly easy, it's quite fast. We are working on existing data set. We don't have to wait for our predictions to materialize so we can analyze them. We are basing our model only on the historical data. And we are making assumption that more training data means better predictions, which is the biggest pro. And also it's a con of this model, because what if not? Like, what if we are introducing more variability in the process, and if that period directly before our intervention is actually so different than the training data that we had before that our predictions are completely wrong. And this is how one of the KPIs that we've measured over the last 2.5 years looks like. As you can guess, the low points are weekends, and this is a KPI that is relating directly to job searches, and it's a pattern that we see pretty much in all of our metrics. So there's a lot of noise. We can't really do anything about this. People don't search for work on Sundays. And here on the top chart, that we have the train and test period. We are training, testing, checking how good the prediction was on the test, then retraining on all of the data before intervention, making predictions, and hoping that the model is okay. And yeah, this is Python conference, so maybe I should show it. No. Sorry, I'm not doing live coding here. There are too many people looking at me, and I will be making too many mistakes. So I'll just go with you through the analysis and try to explain how to do it simply and fast. So first we start with our intervention date. We have to know when there was a change in the process. We have our data set, which consists only of the timestamp and the value of the response at that time. Just modifying this a little bit. And it looks like this. Yeah. Who can tell where the outliers are? Yeah. With all models, with all time series, there's a high chance that you will get some weird day that something spiked, either because there was a huge conference that day in that place, or because simply the model broke, our logs were incorrect, we double counted some users. We have to get rid of outliers before we can do any further analysis. So what I'm doing here, I'm just looking at rolling 90-day window, 91-day window, and looking for values that are outside 3 sigma range for that day. And I found one point that is this spike here, but I will actually use a little bit more relaxed, and I'll say it has to be within 1.6 sigma range, and this value I've checked before, so that we get all these outliers that I will replace with the upper range of the prediction for that day. And I'll show you the differences now. The blue is the original one, and orange is the time series that we'll be analyzing. And here you can see what were the values of outliers, by how much I've corrected the historical data so that I can use it for training the model. And the idea here is that the model is robust, but the more noise we introduce, the more variability in the prediction. And we know that we are only looking for like general pattern over time, not for specific to date. Like it will not, our process will not change by 100% day to day. And the whole fbprophet training part actually takes 3 lines of code. And with these 3 cells here, we already built our model that does not use daily seasonality because I have data that is split by day, not by hour. That's a really good thing because here with fbprophet you can actually feed it hourly data and then see what's happening at midnight or 9 a.m. And the model produces a chart like this, where the dots are the actual values. The dark blue line is the prediction for a given day, and the light blue area is our confidence for that day. It's upper and lower range for prediction for each day. And we see that it's fitting data pretty nicely. Like, it's not perfect, but it's a good first try. And the model discovered that this is our overall trend over time. So we see that since 2015 February, it was growing rapidly until end of 2015 and started slowing down. The growth is slowing down and we are almost reaching like flat line. During the year, it fluctuates a lot. January 1st, December 24th are the lowest days during the year, which is kind of obvious, but then we see all the impacts of the holidays, end of quarters, first Mondays of each month, which cause a lot more traffic on the site. And during the week looks like this, but unfortunately the chart goes from Sunday to Saturday, which is not a typical way of showing it here, so I'm just going to change it a little bit. We see people or users on the website start on Monday. There's actually more traffic on Tuesdays, and then starts to slow down on Saturday and Sunday. We have barely any traffic compared to Monday. And the model, when we include separate parameters, this is how the actual values look compared to the trend. It's not good yet, right? But when we include the yearly seasonality, it starts looking better. And when we add all the components of the model, which is basically for each given day, what was the value of the trend, plus what was the value of that day, of the seasonality on that day, and seasonality on the day of the week, produces a model that fits data really, really nice. And the approach of testing, training, testing, and retraining. Here, I'm now testing how good the model is at predicting the period before the intervention. So I will take 1.5 months to basically train a separate model with the same parameters, give it less data, only up to the test intervention, and this is how good this model is at predicting the value. So orange is actual, blue is our prediction plus the range that we predicted the actual value to be at. Seems to be okay. There are a few tests that we can run to validate that they are actually matching, except for just looking at the chart, because that's not a test yet. This is just an indication. And there are not too many tests that we can do on this. So here I'm basically testing if the mean of the two is the same with t-test, and I can verify that, like, this way I can verify that the two distributions, that the two processes have the same mean, or I'm not rejecting the hypothesis that they are different. I'm running another test to see if they come from different distributions. So it's a much stronger test. It's Kolmogorov-Smirnov test that is basically non-parametric comparison of two samples to say if they are from the same distribution. At p-value of 0.05, we can reject we reject that they are different, and we conclude that our prediction in the pre-intervention period was good and was matching what actually was happening. So to build a forecast, this is the same model now, but after the intervention date. And again, we are looking at the chart, we see that it's different now, but the difference starts to appear after our intervention date. We have all the indications to say that whatever we did on that day, on the 6th of March, made a change in the process. Here it's only a little bit zoomed in. And we also see here, this is the rolling mean of the effect of the uplift. Before the intervention, it's oscillating around 0 and then starts, like rapidly goes up, and know that what actually see in the chart is really what we are looking for. It's an uplift of value that I'll measure in a moment. Here I'm doing the same test to check if the means of the two are the same. And with p-value of 0.01, we can reject the hypothesis 0 that they are equal, and we actually will accept the fact that the means of the two processes are now different. Before intervention was the same, now it's different. Assuming that our intervention was the only factor changing the process, we can now say that the test was successful and we've achieved uplift of 18, 19 units and roughly 23% uplift. There are a few additional metrics that we can run on this model. We can see the regression, or R-squared before and after, where before it was at 0.9, which seems to be a good match. And after intervention date, it went down to 0.65. Our mean square error went up from 0.03, 0.04 to 28. We have all the evidence that we would need to have to conclude that this marketing activity was effective. We predicted what should have happened. Something completely different happened. We had 23% of the effectiveness of this campaign was uplift of 23%. So the whole process, one more time, is really simple. We take our time series, try to remove outliers, try to get a good representation of what was the actual process, build a model without tweaking parameters at first. We just want to see if it works. After finding out that it's actually a good model for predicting this type of data, we start tweaking the parameters using whatever method we want. We analyze the seasonality to search for any errors in this. If we are expecting to see the value to go down on Christmas, if it goes down, this is only validating our hypothesis. We check the model if it was performing good on data before the intervention. And then we run the same model, assuming that since it was working fine before, it should also be working fine after. And whatever difference we find now is something that we can with quite high level of certainty say that this was attributed to the campaign. Go back to our marketing director and say that whatever he did in that market should be replicated on the country level with a higher budget. That's it.